Thank you for viewing this recorded Reliable Automatic Sprinkler Company webinar. Should you have any questions regarding this presentation, please feel free to contact Reliable Technical Services at 800-557-2726 or email us at techserve@reliablesprinkler.com. For upcoming webcasts and an archive of past webcasts, please visit reliablesprinkler.com/webcasts. Once again, thank you and enjoy the presentation.
Thank everybody for attending today. Now let's jump into our topic here today, which is the protection of attic using sprinklers and special sprinklers. If we take a trip back in time to when I first started design, I utilized NFPA 13's 1999 edition, and that particular edition incorporates some protection of attics using standard spray sprinklers that's very different than what we see today. And this is also right around the time when attic sprinklers, specific application, special attic sprinklers were brought to market. If we look at what was considered to be an acceptable design using that NFPA 13 1999 edition, it could look something like this on a gable roof. We were allowed to have sprinkler coverage that was up to 130 square foot. And in this instance, we could space it, let's say 14 foot by 9 foot. And we would be able to install those sprinklers up to 3 feet down from the peak. And our calculations could utilize 7 PSI using a layout like this. And if we wanted to bury these sprinklers down at the eaves, let's say 3 feet away, that was considered to be totally acceptable. Now, what we need to understand is that with attics, these have a very unique geometry that doesn't lend itself very well towards activating sprinklers if the fire starts in the wrong place. And one of the worst places that we could have a fire occur is somewhere down at the eave. And if it starts in between these sprinklers, it allows any kind of heat that's generated from the fire to bypass sprinklers and go up towards the peak. So if we take a look at what could potentially happen, we'll start a little animation here that shows a fire, and that heat goes to the peak and it starts to move laterally once it hits the top. And we're going to get activations somewhere around the peak once that void space fills up. And we're just not going to get what we need where the fire is occurring right away. So this could all cause some detrimental damage to the structure and really not allow us to control and contain a fire like NFPA 13 is really supposed to allow us to do. Now, once this was all realized, the industry got together and went through a series of full-scale fire tests that were performed at UL laboratories. And they were able to identify the shortcomings of the NFPA 13 1999 edition and create new criteria that was first incorporated in our 2002 edition of NFPA 13. So what we know is that since 2002, every subsequent edition of NFPA 13 has virtually remained unchanged. So the criteria developed through those 6 full-scale fire tests and implemented by NFPA back then has been considered to be adequate control and containment of fire protection in attics. So the changes that really occurred was, number one, smaller area of coverage per each sprinkler. Number two is the maximum spacing between the sprinklers was going to be limited. And we would also mandate that sprinklers be installed at the peak. And the sprinklers installed a minimum distance away from the eave. And based upon how a layout technician chose to space the sprinklers, it could result in the need for a higher operating pressure when it came time to do your hydraulic calculations. If we look at this table found in NFPA 13, 2016 edition, reference 86221A, you'll notice at the bottom here, we now have this combustible concealed spaces in accordance with 86414. This is basically code for attic. So this whole section here was added just specifically to deal with construction that we most commonly refer to as attic spaces. And we'll notice that the spacing has been reduced from what used to be 130 down to 120 square foot. We'll also notice that we have some spacing requirements on how to apply that sprinkler. So it's going to be 15 foot parallel to the slope and 10 foot perpendicular to the slope. We have the mandate now to put sprinklers located at the peak. And this is a very important feature to the new attic sprinkler layouts, because putting the sprinkler at the peak is going to allow any kind of heat that bypasses lower sprinklers and collects at the peak to activate those sprinklers faster than if they were located up to 3 feet away. Now, although those sprinklers activate, and if the fire's down at the eave, we're not going to be really discharging water on the fire area. Just the fact that we're discharging water into the attic, we're going to begin that cooling process as the water reverts to steam and starts to displace oxygen and cool the environment. So it is a very beneficial thing to have sprinklers just even start to go off in this space, even if they're at the peak away from the fire. The next requirement is the distance from the eaves. So now we have to install sprinklers down at the eave, and even though we could, bury them down in the eave, and they would, be able to provide coverage when they spray, it really is going to impact their ability to activate. So now there's this minimum requirement to space them 5 foot away, measured along the slope. And what this does is it gives us a fire that starts all the way down at the eave, which is a very common phenomenon, because a lot of times these types of fires start outside the building, they go up the exterior, and they're able to penetrate into the attic from the eave. So if that sprinkler is too close, the heat generated from that fire could just bypass those sprinklers. By pushing them back 5 foot, we're giving them a fighting chance at that fire, even if it starts in between the rows of sprinklers, that the fire grows a little bit laterally before it goes up too much and it activates the sprinklers and potentially keeps that fire in check. Now, while things remained relatively unchanged since 2002, we did start to see some activity in the 2016 edition that incorporates some guidance. It's not changes to the standard language, because the changes that occurred were actually part of the annex. And we know that's not part of the adopted standard that would be considered to be enforceable code in some jurisdictions, but just having it written and in the document is very helpful for sprinkler contractors and HJs to navigate the world of applying NFPA 13. So what they did was they put this measurement point figure inside of the standard. And this is very helpful, because it all reverts back to where is that point that is 5 foot minimum away from the eave. Well, the guidance is going to be from an uninsulated attic that you're going to have where the top cord and the bottom cord of that ceiling joist meet. That's going to be your measurement point, not outside of the building where the walls are at, not outside where the edge of the roof is at. It's really that intersection point. Now, if you have an insulated attic, which is very common, that point gets moved up a little bit, because you're going to then have this insulation and the top cord intersection be your point of measurement. So these are just very helpful figures that really allow you to, explain and rationalize your design and allow you to maximize the coverage out of every sprinkler that you're putting in the attic. As it relates to the special sprinklers that are used for attics that we manufacture, this is also the guidance that we provide for measuring the application of those sprinklers as well. When it comes to attics, we would love, from a sprinkler design perspective, to say everything that comes across our desk is a gable roof, but unfortunately it's not. We end up dealing with strange geometries, and a very common way that roofs are terminated on the ends is to have a hip. And a hip is just taking that gable and then sort of folding it back on itself. This does cause challenges when it comes to laying out sprinklers, and it's always been a question of how do you handle the corners. So fortunately, again, 2016 in the annex, we finally get some guidance on this. And what we're going to see is that we have this eave line indicated by the dash, and we have two scenarios here. On the left, we have spacing sprinklers on both sides of the hip line, and in that instance, we're going to be able to measure the 5 foot minimum away from the eave, and then we can also be a maximum of 5 foot off of our hip line. So this is two sprinklers located on each side of the hip line, respecting the minimum distance here, and then also having a maximum distance off of the hip. Option number 2 is to space sprinklers on the right-hand side here directly under a hip line. So we place a sprinkler directly under a hip. In order for it to be considered directly under the hip, it's going to have to be within 4 inches of each side of that hip line. So we mount it between there, and then we're going to have to respect the distances off the eave, which is indicated by that dashed line once again. So if you start looking at this from a sprinkler design perspective, this side over here seems pretty reasonable. Everything's good because we're 5 foot minimum off the eave. We're going to be 5 foot minimum all the way around, and we get good coverage. But if we use this opportunity to space like we do on the left here, where we're going to be 5 foot off of the eave and then 5 foot off of the hip line, basically what you end up discovering is that you probably have this area of coverage that's lacking in the attic. And what's nice about this figure is that it's saying it's okay to have that uncovered area as indicated by this yellow box here. This is really helpful because what is different about attics and hip areas is that this is all funneling down all the way to this point right here. So really this yellow box, there's really not that much area that's out there to protect with sprinklers. It's not a high space. The fire that potentially starts in this area is going to be really well contained just because of the construction. And the only place it's going to have to go is up the hip line, away from this area, towards sprinklers. And those sprinklers are going to be able to discharge, and we hope be able to offer that control and containment. So these two options are very helpful when it comes to laying out hips using standard spray sprinklers, and giving this guidance is really good for discussing the application with an AHJ. Next change to discuss is higher operating pressure. Now we went to this table as one of the first things we discussed that talked about limiting the amount of coverage from 130 to 120. If we look at this, it's actually allowed to be done as 15 foot parallel to slope, 10 foot perpendicular to slope. If we did the math on that, that's 150 square foot. So we can't take advantage of both of those spacing options that are outlined here. Those are maximums that are allowed to be used in either direction according to the slope. So if we did this in a way that would make the 120 work, one way to do that is, let's say, 12 by 10. That's 120 square feet. But basically another way to do that is going to be 15 by 8. That's another way to do 120. 15 by 8 is a really good way to do it because there's no problem with that. If you go with something like a 12 by 10, you are now going to have to take into effect this asterisk right here, because that's going to refer us over to 86414. And that's where the higher operating pressure comes in. So 864144 says sprinklers installed where the dimension perpendicular to slope exceeds 8 foot shall have a minimum pressure of 20 psi. Now, with a regular attic design layout, one that is maintaining that 8 foot measurement, we could calculate using 7 psi. And we know that's the minimum that we're allowed to calculate sprinklers at. So that's where we probably would like to be in order to maximize the water supply that we have. We're not going to cause an over discharge situation. So if we end up going over that 8 foot though, 20 psi becomes a factor. Now, what is that really doing to us with hydraulics? Well, basically, if we do a 5.6 K factor sprinkler and we multiply that by the square root of 20, which is our PSI, we're going to get a flow rate of 25 gallons per minute. Dividing that by 120 square feet is going to result in about a 0.21 density. So we take a attic space that should be designed to a light hazard density, which is a 0.1, and now we're going to flow water at a 0.21, which is in excess of a ordinary hazard group 2. I can't see anybody wanting to do this layout to exceed that 8 foot, but maybe there's a reason. And if there is, you can use that chat function to let us know. But honestly, in my design career, it's never even crossed my mind to try and exceed that 8 foot. I just never felt I would justify any savings to generate all that extra water in the calculation. Now, that's twice the normal light hazard density. And when we start thinking about what happens to the remote area through the process of, in areas that are using dry systems, we're increasing it by 30%. And we're also needing to increase by 30% just because it's a slope. And we're looking at a 2,535 square foot design area with a 0.21 density. And if you've ever calculated or designed an attic, you know that over discharge is a big function of that type of system because of the change in elevation from the eave to the peak. So it's just really going to be a very difficult calculation to try and work out. And then also, just as a blanket statement, with all the criteria within NFPA 13, the opportunity to use CPVC is just not possible. It can't be done whether it's a wet system, a dry system, utilizing standard spray sprinklers. So those are all things that really impact us. Now, if we take a look at that same attic space that we just discussed before, and we lay it out utilizing NFPA 13's current layout standards, we're going to see right off the bat that we have more sprinkler heads. It's just visually, there's more sprinklers. Everything's a little bit more compressed. And most notably, we have a line located at the peak. And that's resulted in going from a 4-branch line scenario into a 5-branch line scenario. So more sprinkler heads, but more branch lines are going to result in a higher, larger amount of labor that's required to do this installation. But we are doing that 120 square foot spacing. We've kept the spacing between the sprinklers to 8 feet, which is good because that keeps us at a 7 psi minimum inlet pressure. And we've made sure to install the sprinklers 5 feet away from the eave. Again, worst case scenario for an attic fire is one that starts at the eave and one that's in between sprinklers. When that happens this time, that heat will rise to the top, and with those sprinklers located at the peak, they're going to activate much quicker than the ones that were not at the peak and 3 feet down. And this narrow channel in between sprinklers is meaning that the fire, even though it will continue to grow with those sprinklers discharging at the peak, the ones below it are going to have a good shot at activating as that fire grows, because it's just a smaller space in between the sprinklers. Fire gets larger, activates them. And what we want to see out of this, what we believe is going to happen if this is done correctly according to NFPA 13, is this effect where we really surround the fire, we keep it trapped. It's not going to go laterally across the roof, and that should basically be the extent of the damage that we're going to see from the fire. Just to run through some of the hydraulics of this type of system, we have another attic here laid out with standard spray sprinklers, and we have 75 sprinklers in this example. And when we do a calculation with a wet system, we would be able to have a much smaller remote area. We'll start by saying that we have a 1,950 square foot, so 1,500. We're going to multiply that by 30% because of the slope and take it to 1,950. But because we're working with a wet system, and because we have those quick response sprinklers, we can employ the quick response reduction that's found in NFPA 13. And with the 10'6" height, the reduction could be 39.3%. That'll get us down to 1,185 feet, 13 sprinklers in that remote area for this layout here. Now, one thing that's unique to people that are probably looking at this and don't really get to do wet system attics is that we have some flexibility because we can use K factors that are smaller than 5.6. In this case, a 4.2 K factor really makes a lot of sense here. That we want to stay as close to 7 psi as possible. So at 120 square foot with a 4.2 K factor, we'd be discharging about 8.2 psi. We need 8.2 psi to discharge 12 gallons per minute. If we were to go with a 5.6 K factor sprinkler, our PSI at our end sprinkler would end up being around 4.6, resulting in flow rates that are going to be higher than 12 GPM. We don't want to do that. So adding an extra 1.2 pounds at our most remote sprinkler to get that minimum flow rate is really beneficial in this instance. And if we add up all the sprinklers that are going to flow in this instance, all 13 of them at that 12 gallon a minute flow rate, we would need 156 gallons as our minimum hydraulic demand. And I say minimum because obviously with changes in elevation from your peak down to your eave, you're going to have higher PSI driving these sprinklers. The layout of the system is going to impact all that. So theoretical minimal, 156 gallons per minute for this type of layout. It's going to be more than that in reality though, and we need to be aware of that. Same attic, once again though, laid out with dry system, we end up having more sprinkler heads because we have that increase for the slope, and we also have the increase for dry system. We can't do any kind of reduction for quick response sprinklers. we're calculating that full 2,535 square foot, resulting in 27 sprinklers in this instance. And as I said before, with dry systems, we ultimately almost always default to 5.6 K-factor sprinklers because the most economical piping material is steel that's black, not galvanized. If we had galvanized, we can maybe play with that 4.2 K-factor a little bit. But in this instance, black steel pipe, 5.6 K-factor. We're going to now need 7 PSI for the sprinkler. It's going to be more than the coverage area. We're going to overdrive those sprinklers a little bit, an extra 2.8 gallons a minute. And the hydraulics for this one, minimum 400. And just from experience in the past doing design, this number tends to pretty much skyrocket. We see demands that are in excess of 600-700 gallons a minute with this in certain instances in attics. So the 400 GPM, it's just a baseline. It's a minimal. We got to be prepared to flow more water. And while a gable is always the best way to do these types of attics, we do have these hip scenarios that we need to be aware of. In this instance, a hip end on this attic, 65 total sprinklers. Once again, doing our hydraulic layout here. Wet system, we're going to do that 4.2 K factor because that's what we feel is to be best with black steel pipe and wet systems. Root area is about 1,170 square feet, 13 heads, 156 gallons a minute once again. And now we look at our hip sprinkler, our hip layout with our standard spray sprinklers on a dry system, much larger area, needing 29 sprinkler heads, and ultimately 563 gallons per minute when we calculate the minimum flowing of all those 29 heads. So moving on, we just covered NFPA 13 in depth about using standard spray sprinklers. The common question I'd ask most people in our audience today is, what about NFPA 13R? What does it say about attics? What have we done in the past with buildings that are protected to this standard? And the common answer is always, it's 13R, I don't need to do attics. And that's true because if you look inside of a copy of NFPA 13R, we see sprinklers shall not be required in attics, penthouses, equipment rooms, etc. So it's pretty clear, you know, with NFPA 13R being a standard that is driven to provide life safety inside of low-rise residential occupancies, the idea of protecting an attic is just outside of the scope, because up there in the attic space, we're not expecting anybody to be habitating or up there, so life safety is not really a concern in that space. However, if you haven't been keeping track of things in recent years, there's been multiple fires that started in attics in properties that are protected to NFPA 13R standards. There was no loss of life in these fires, but a very large loss of property. It actually prompted NFPA to host a summit in 2015, just to bring all the stakeholders together, whether HJs, insurance companies, manufacturers, property developers, really to try and discuss this problem, to find out, is NFPA 13R a standard that is deficient in some way? After the summit, there was several changes that were made to different standards that are published. The biggest one was really identifying how pedestal or podium style construction led to some of these fires. And that prompted the IBC to change the way it handles that type of construction in the 2018 edition, which is, you know, currently published and available, possibly even adopted in some areas where you work. For those who are unclear about what pedestal or podium style construction is, it looks something like this. We have a portion of a building built on the grade that is different than residential. It could be multiple stories, it could be retail, it could be some office space, it could be parking. But the key to this whole thing is that there's a 3-hour separation that's implemented. And then on top of that 3-hour separation, you could then build another structure that is of a lower type of construction specifically for residential occupancies. And once you did that, it was acceptable to utilize NFPA 13R standards for that type of fire protection there. Now, obviously, you could see that there could be some challenges to the way this is implemented in the real world. If we have multiple stories down here that really elevate this residential structure, it's no longer really a low-rise type of structure, which is why it was changed to indicate that if that attic, EAVE, ended up being 55 foot higher than the road surface where the fire department could actually arrive and produce or do their fire protection operations, we would then have to consider that something that's protected outside of NFPA 13R. Go all the way up to NFPA 13 type of protection, look at using sprinklers in the attic. So it just completely changes the scope of things. If we just think about this though, the way it is, if this was a single story, let's say it was a retail space, we'd be generous and say that it takes 15 foot of spacing right there. And then we have 10 foot for every residence floor. That's 55 foot, assuming that the grade is relatively flat. So this isn't a real problem when we look at having a single level on that podium. But if we go to multiple levels, it's going to be a bit of a challenge to keep that NFPA 13R occupancy. So it was a good change that may or may not be something that you see coming across your area. Naturally, though, if the change takes place to IBC that is going to some way, shape, or form indicate that you need to protect the attic, naturally, NFPA 13R should do something about that, which is why in the 2019 edition, we have this new section that's called Other Attics. And it says attics that are not required by 741 to have sprinklers shall be permitted to have protection in accordance with one of the following. Number one, protect complying with NFPA 13. So everything we just discussed could now end up being applied to an NFPA 13R building. And we just illustrated through some hydraulic demands that the demands are very high in some instances. And when we think about the nice low flow residential optimized forehead calculations that are the hallmark of NFPA 13R, an NFPA 13 attic could really blow that right out of the water. So that's option number one. Option number two is extremely interesting. Protection using sprinklers specifically listed to provide attic protection in residential occupancies using a discharge density of not less than 0.05 gallons per minute per square foot, and a density and a design area of not less than 4 sprinklers. So in case you're wondering, that product doesn't exist. It's just not available in any manufacturer's product lineup. But it does open a door for a manufacturer to make such a product. So that's interesting from that respect. What's also interesting is the implementation of the ability to use a 0.05 density in this attic space. Because as we know, 0.05 has been traditionally reserved for life safety. When it came to property protection, it was always a 0.1. So now we have this mix of things of really reducing the amount of gallons per minute that might be required for these types of heads, and then also a limitation of 4 heads. You could really cut down the number of sprinklers as well. So very interesting stuff. It's worth watching this space to see how this shapes out over time, the way the IBC has knocked over a domino and now it's going to NFPA 13R, and then ultimately, what do the manufacturers do to possibly answer this? Now, if you thought we were done, that was a lot of changes coming up to NFPA 13R and IBC, things are going to get a little bit more complicated, because with the IBC 2021 edition, which has not been published, it's been finalized, but hasn't been published, they revisited this whole topic. And now they're more concerned about just total height of the building. So that pedestal construction, if the highest floor of this whole structure ends up being over 30 foot from where the fire department's at, it's going to, not allow the use of NFPA 13R on the top there. This is going to kick the whole thing up to an NFPA 13 type building, and the attic subsequently gets protected that way. So that's a big change, but this is also the type of change that would make it more in line with the way we apply standpipes to structures. So that's what they're really trying to do, is bring everything back together with, if you need standpipes in the building, then the whole thing should just be NFPA 13 at that point. And while I'm showing you pedestal right here, this is also going to apply to just a regular multifamily building, something like a hotel or apartment building. If you end up having that top floor be 30 foot from where the fire department access is, then you're going to end up needing to move up to NFPA 13. Now, this is, again, one of those things where if you look at this right now and we just say, hey, every one of these floors is about 9-10 foot apart, then this shouldn't be a problem. And that's assuming that the road surface is relatively flat with the building and everything's fine. But we know when we're dealing with structures that are on terrain, the backside of the building might drop off, and that might end up putting that higher floor above 30 foot. So all things that need to be looked at and considered as these standards are adopted in your jurisdiction, and you start to see buildings that you've designed for years a certain way now might end up taking on a new light on how we're going to apply these standards. So moving on to why would we want to use attic sprinklers? There is several reasons. These types of sprinklers are going to offer better fire protection because of multiple factors. Number one of the biggest things about them is that they mainly are installed where the heat collects. And that's important because that may not be where the fire is. But once they do activate, those sprinklers are meant to deliver water to where the fire's at, which is hugely different than the way we apply standard spray sprinklers. They usually result in fewer branch lines, and the number of sprinklers goes down as well. These sprinklers from the very beginning have been designed to work with CPVC on wet systems. And that can be huge as a flexible, cost-effective piping material to utilize in attic spaces. There are smaller dry systems that result out of this, so the volume goes down. This also helps out with creating systems that transit water better to the most remote area. And every single one of these sprinklers that we'll talk about, that's a special sprinkler specifically listed as an attic sprinkler, has been validated by actual fire testing done at underwriters' laboratories. With the attic sprinklers, these are considered to be special sprinklers according to NFPA 13. So the key about special sprinklers is that they are outlined in Chapter 8 of NFPA 13. They have a list of things that we need to take into account when we're making these types of products. Number one is, we have a fire test that's related to the intended hazard. So we need to build an attic and we need to have a fire test in it. We have distribution of spray pattern with respect to the wetting of floors and walls. It's basically critical. We put the sprinklers in there, make sure that they end up flowing through all the web members and everything else that we need to wet what we need to wet and protect that attic. Distribution of spray pattern with respect to obstructions. Attics, as we see now more and more with the pre-engineered trusses, have a lot of web members out there. And the nice part is that we test with the web members, which ultimately means that they're not going to be obstructions. If we test with them, then we can say they're not considered to be obstructions. And we'll evaluate thermal sensitivity. We know we need to have quick response because we're in an attic space. So that's what we're going to make sure that the sprinklers are utilizing those types of operating elements. And performance under horizontal slope ceilings. For this type of sprinkler, it's basically always sloped. So that's what we're doing. And the area of design will be quantified, and then we'll have allowable clearances to ceilings. So this is how we place our sprinklers. So doing all those things really allows NFPA to have these special sprinklers be created by working with a testing laboratory like UL, and allows our company to bring them to market. The test program that's put together at UL right now is what's known as an outline of investigation, and it's called UL 199G. And the thing about this, the key word is outline. If this was one of the standard UL test programs, like standard spray, like extended coverage, like storage, we would go to the laboratory and we'd have a barrage of tests that are very specific towards those types of sprinklers. We would develop those sprinklers, and they would all come out and they would pretty much be identical clones to every other storage, extended coverage, standard spray residential sprinkler that's on the market. With this outline of investigation, though, there's a lot of freedom and a lot of latitude for a manufacturer to go to UL, develop sprinklers that have unique spray patterns that flow different flow rates, and ultimately can be listed, and it just creates a completely separate, different sprinkler type than what our company makes versus one of our competitors. So it really is one of those things where we have to keep an eye out and make sure that we look at things, because they're just not always going to be identical cookie cutter clones of each other. So the one thing that's really important to look at here from a standpoint of when we test these products, what we're trying to do is make sure that we capture the number of sprinklers operated, which is important for the hydraulic calculations, and that ultimately gets translated to our technical bulletin for use by sprinkler designers. We also have sprinklers installed at the peak near the end of a test room, and we want to make sure that they don't operate. So the minimum test room is going to be 52 feet. We'll put sprinklers off the peak, we'll activate a fire down at the eave, and we make sure that the sprinklers in the middle of that room activate, but we don't want the ones to activate at the end. And what we're trying to do is prove out that the sprinkler was controlled from growth going laterally in the attic space. And that's important because it allows us to say the sprinklers are not going to dictate that we have to start compartmentalizing our attic space to make sure that the sprinklers are going to operate. This is one of those things that cause a lot of angst when we're working with concealed combustible space sprinklers, because we have to typically install the draft stops and make smaller compartment spaces. With the attic sprinklers, that type of stuff is not in our technical bulletin as a requirement to use these products. They can be in an attic that's 500 foot long if you want to, and not have to worry about it. So the last thing, though, is one of the most impressive features here, is that after we run this full-scale fire test, we have to make sure that a roof deck breach caused by the fire doesn't exceed 6 square feet. That doesn't sound like that big of a deal, but we'll show you in a little bit why that might be a big deal. And we just understand that it's just such a small number that it's 6 square feet. So here's our attic space with our dual direction products located at the peak. Same attic that we looked at before that had 4 lines originally. We had 5 lines the next time we saw it. Now we're down to a single line of those dual direction sprinklers. And our fire event occurs down at the eave. It goes up to the peak, it activates the sprinklers. And this time the big difference is those sprinklers, quick activation because they're quick response, but they're not just cooling the peak, they're now delivering water down to the eave where that fire is at, which is really going to help control and contain this fire scenario better than anything else that we've shown you up to date. So now let's take a look at a video of our test. You'll see here we have our test room set up, and we have our dual direction sprinklers located at the peak. We're going to start our fire down here at the eave. Now, one thing that you want to just notice right off the bat is that this wood crib down here, which has fuel in the bottom of it, it's pretty much touching the underside of the roof deck. And now I think you can start to visualize why 6 square foot is such an impressive number, because the minute you light this fire, you're already starting to degrade the roof deck and potentially getting to that 6 square foot burn through. So let's take a look at what happens here. So we have our fire ignition, and that's going to start burning that crib of wood there. And immediately, fire is touching the underside of the deck. Now what's going to happen here is we're going to keep this uncut, and we're going to actually fast forward here. It's going to move about 10 times the speed of real life, and that's going to get us about 5 minutes plus into the future here. And what you'll notice is that this fire, it's growing right up the slope, and the framing members are channeling it and keeping it pretty much going that direction. We're starting to see some growth in the next channels at this point, but here we are, 5 minutes, we're back to real time, and it's a small, reasonable fire. We still don't have a sprinkler activation. In fact, we're going to have an activation basically right now. And that's at the 5 minute and 32 second mark after our fire ignition. What you'll notice is that there is no water coming out of these sprinklers, even though the first one is activated. And that's because you're watching a test that's trying to get us criteria for a dry pipe listing. And the way we do that is we withhold water for 60 seconds. And that 60 seconds is being indicated by that yellow circle down there on the bottom. And this is real time, as I said, and it's not sped up. And you can always see how massive this fire gets. And then it's one of those things that we often hear in our industry, that fire grows exponentially. And this video, I think, shows that more than anything. We went from a small, well-contained fire at the time of our first sprinkler activation to this much larger raging fire in a dry system. And there's our GoPro tilting from how turbulent things are getting inside of there. And now we're going to actually get our water discharge. And amazingly, within a few short seconds, just getting that water going off, we're able to beat that fire back down. So very, very impressive way that these sprinklers can control and get this fire knocked down. And at this point, we're going to continue to let this fire burn. Final extinguishment may occur with these sprinklers, it may not, but we're going to let this go for 30 minutes. And after that 30 minutes is done, UL is going to go in there and they're going to end up taking a poker and they're going to poke around on that roof. And basically, you're going to lose some roof material there. And when they do the math and they figure out, is it less than or greater than 6 foot, you're going to know if you passed or failed the test. It's one of the most difficult things that we have to do from a fire test standpoint to really hit that performance metric. And it's worth mentioning that the performance metric that we have here is something that's not even in NFPA 13. NFPA 13 doesn't guarantee that if you do the sprinkler system their way, you're going to get less than 6 square foot of burn through. In fact, some of the research tests that were done to actually change NFPA 13 had a result of something like 70 square foot of burn through. So that's what maybe NFPA considers to be controlling and containing that fire, damage to 70 plus square foot of the roof. So once that whole testing is done, we hope to get those sprinklers that are going to offer a nice hydraulic design benefit, give us the ability to use CPVC on the wet system, something that doesn't require an increase to the slope because we're testing under a slope. And most importantly, every manufacturer could potentially have their own requirements because it is an outline and not a standard that we're testing to. So we have these sprinklers as well. Standard spray, just an example. We have 5 branch lines, 75. And that attic sprinkler design, same attic, down to 1 branch line, 20 sprinklers, significant savings in sprinklers and branch lines, and also with water demand. So here's one thing that we need to understand as well with special sprinklers. They're not tested under every possible scenario. We have a bulletin, we post a lot of figures on the way we tested it, and then also some ways that UL has given us some guidance on how to handle these situations, but it doesn't possibly handle everything that you're going to encounter out there. What's important to understand is that NFPA is not necessarily silent on the issue. Basically, if we look at Chapter 8, we're going to find that it says sprinklers shall be installed in accordance with their listing. And right then and there, it's like, hey, pull out the bulletin for our product, look at it, and do what it says. But you got the situation that just doesn't work out. That's why it's nice, because right after that 8311, we get this. Sprinklers shall not apply. You know, the requirements of using their listing shall not apply where construction features or other special situations require unusual water distribution. It gives the sprinkler contractor, the design technician, an avenue to have a discussion, to put it in the hands of the designer, the HJ, to work it out, to find a way to say, hey, this doesn't look exactly like the paperwork that is out there for the sprinkler head, but how do we make this work? And it really is a jumping off point to be able to talk. Now, beyond that, I mean, we're always happy to help. So if you can't use this portion of NFPA 13 to your benefit, then feel free to reach out to us. We'll be happy to talk through the situation and get some guidance. And if we can't offer guidance right away, we can always go to UL and see if they have an opinion on the matter themselves. The other thing that we just talked about a lot, these sprinklers have the potential to be very different as you look at different manufacturers' products. So the idea of taking a sprinkler and cross-referencing it is something that should not be done willy-nilly. You should really look at what's out there. And as we always say, all attic sprinklers are not created equal. So we want people to really take a look at what's out there and ultimately pick the system that's best. And it always works best when you identify the benefits of these products at the beginning of design and start with them that way, rather than getting halfway down the line and then deciding that you want to shift gears to another manufacturer, because it calls into question maybe a lot of aspects of your design that's already done, possibly coordinated, etc. Now, with all that out of the way, we just want to let you know that Reliable does have a full line of attic sprinklers. We've had them available since December of 2016, I want to say, and basically they have 4 different sprinklers that are part of the lineup, 4 unique models. We have our direction single, our direction dual direction, our general purpose, and our attic hip sprinklers. Every one of these sprinklers has been fully tested at UL. They're listed under the special sprinkler category for attic sprinklers, and we have all the information published for these products in Technical Bulletin 056. Another unique thing about our sprinkler lineup is that they utilize 212-degree fast response fusible link operating elements. Reliable feels strongly that this is a preferred method of operating element for a sprinkler such as this, considering it's going to go up into an attic, more than likely never be looked at again, and offer the durable, long, time-tested operating elements that fusible links can offer to you. So we invite you to watch part 2 on the 16th, I believe, is the date, to learn more about these sprinklers and their capabilities. You have the ability to look at the bulletin right now if you want to catch up, study up on that. Should you have something you want to talk about in the meantime, reach out to technical services at 1-800-55-RASCO or email techserve@reliablesprinkler.com. We do thank you for your time today, and we do have some time available for some questions now.
Hey, Brandon, it's Carrie.
Hi, Carrie.
Hey, we got not too many questions. I took care of one here, but there is one question that just came in, and I'll let you handle this. It said, would these sprinklers qualify CPVC to be used in a dry system in an exposed combustible attic space? And he used the very specific word now, as though something might have changed.
Well, I am unaware of a change, and I feel that UL is basically of the opinion that it has to be a wet system. I am not aware of any change that allows for that.
Yeah, and I agree, and there may have been the way you had phrased something that led someone to believe that, and for the person who sent the question in, a large part of the ability of CPVC to be used on these systems in general is the fact that they are filled with water. So once you take that water out, a lot of the heat sink has now gone away. That piping is very prone to failure at that point. So basically the answer is no. And then the other reason is that currently CPVC is only listed for a maximum of 15 psi of air pressure. So a normal 40 psi pressure system obviously wouldn't work. There may be some other systems that could technically work with CPVC at that 15-pound range, but the testing for these and the listing is simply for wet systems for these special sprinklers. That was really the only other question that we had. So,
oh wow, must have done a really good job.
There you go. Thanks, Brandon.